So I know I'm starting with a screen that has a lot on it. So focus on the right-hand side first. I'm going to show how this reaction is going on. So this is the reaction. I've got a big yellow sphere by itself, and there's a BC that it's colliding with. And what's supposed to happen is that the A needs to collide with the B, and you're left with a C floating around. So once you get things moving in the system, it can be hard to tell exactly what's going on. So basically, if you have a free floating yellow sphere, it's all by itself, the reaction hasn't happened. You're sitting at reactants. When the yellow sphere is like joined with something, then the reaction's happened. So I'm going to come over here and look at this right here. So this is going to be a single collision. And what I'm hoping that you're going to be able to see is that when you collide molecules, just the collision itself isn't enough. It has to be at the right orientation, and it also has to be with enough energy. Before I start it, notice this middle section. You can see an energy diagram. The green horizontal line is total energy. So this reaction is going to be starting with not enough energy. It's going to have to be like above that top curve to have enough activation energy for anything to go. So I'm going to start with it with this low energy. I'll give it a little bit temperature to get it up just a little bit. Oh, it's not going to let me. I got to start it, okay? You can see how slow that is, right? But I'm going to raise up my temperature. And now if you look in the middle, you see my green line is going up. There we go. Now we've got a good bit of energy. Now look, do you see that? Now we have enough energy that when the collision happens, it actually occurs. And it's also, because it's a straight line, it's at the right orientation. They want it to hit exactly opposite and have enough to break it. Now in a second, sometimes with these simulations, you can get it going off to the side. And that's what I was hoping it would do on this one, so that you can see it's moving over. Let's see if it'll do it. I don't know if it's going to do it right this minute. Let me jump onto a mini collision so that you can see it happening here. So in this case, I've got 3 yellows, and they haven't done the reaction yet. And you can see that the green line is really low for this one. So they are bumping into each other again, but not enough energy. So I'm going to raise the energy, but you'll see that even some of them, when they bump into each other, they still won't reactants because they don't have that correct orientation. So I'm going to raise the energy. So now I should have enough to go. I might even give it just a little more. Notice I'm having yellows hit, and they're actually even hitting. But look, I just had 1 yellow react, so that's good. Oh, I had another yellow react, and this is the reason why rate decreases. That yellow ball is going to have a harder time finding the last molecule because there's so many other molecules colliding in its way. So this is, again, why kinetics, it can be hard to make. This is why it slows down, why a reaction slows down. It's just hard for them to find each other. But now what you've seen is they have to collide with enough energy, but they also not just have to bump into enough to each other any old way, but in a specific way. Eventually that one will collide, but this is enough to get you the idea of what's going on.